The topic of the video is recent advances in digital buildings and constructions, AI-assisted programming, coding and software engineering for making highly efficient automated buildings and constructions. Welcome to today's exciting discussion on one of the most significant transformations taking place in the construction and property industries, digital buildings. Buildings are no longer simply physical structures made of concrete, steel, glass, and bricks. Modern buildings are becoming intelligent digital ecosystems capable of sensing, learning, communicating, and making decisions. The convergence of artificial intelligence, cloud computing, digital twins, the Internet of Things, robotics, and advanced software engineering is creating a new generation of smart and intelligent buildings. At the heart of this transformation is AI-assisted programming, coding, and software engineering, which are dramatically accelerating the development of innovative building technologies. Let us explore how these technologies are changing the future of buildings and creating enormous opportunities for businesses, governments, industries, and society. The evolution of buildings. For thousands of years, buildings remained largely passive structures. Their primary purpose was to provide shelter, safety, and workspace. Over the past few decades, buildings became more sophisticated through automation systems that controlled lighting, heating, ventilation, air conditioning, security, and energy management. Today, we are entering a new era where buildings are becoming digital, intelligent, and autonomous. Modern digital buildings continuously collect information through thousands of sensors and connected devices. They analyze data in real time and automatically optimize their operations to improve comfort, safety, sustainability, and cost efficiency. This transformation is being driven largely by advances in software engineering and AI-powered development tools. What are digital buildings? A digital building is a building that uses advanced digital technologies to monitor, manage, and optimize its operations throughout its lifecycle. Digital buildings integrate artificial intelligence, Internet of Things, IoT, cloud computing, edge computing, building information modeling, BIM, digital twins, robotics and automation, cybersecurity systems, advanced analytics platforms. These technologies work together to create a connected and intelligent environment. The building effectively becomes a living digital system capable of understanding what is happening inside and outside the facility and responding appropriately. AI-assisted programming and coding. One of the most exciting developments in recent years is the emergence of AI-assisted programming. Traditionally, software developers spent significant amounts of time writing, debugging, testing, and maintaining software code. Today, AI-powered coding assistants can help developers generate software code, automatically detect programming errors, suggest design improvements, improve software security, create software documentation, perform automated testing, optimize software performance. As a result, software development for digital buildings is becoming faster, more efficient, and more reliable. Instead of spending weeks writing thousands of lines of code manually, developers can now use AI tools to create sophisticated building management applications much more quickly. This significantly reduces development costs and accelerates innovation. Digital twins. The virtual building transformation. One of the most powerful technologies in digital buildings is the digital twin. A digital twin is a virtual representation of a physical building. It continuously receives real-time data from sensors installed throughout the building. The digital twin enables building owners and managers to monitor building performance, predict equipment failures, optimize energy consumption, improve occupant comfort, test different operating scenarios, reduce maintenance costs. AI-assisted software engineering is making digital twin development easier and more affordable than ever before. Developers can rapidly create digital twin applications that analyze millions of data points and generate valuable operational insights. Smart energy management. Energy consumption is one of the largest costs associated with building operations. AI-powered software systems are transforming energy management. Modern digital buildings can automatically adjust lighting levels, control heating and cooling systems, optimize electricity usage, integrate renewable energy sources, manage battery storage systems, predict future energy demands. Machine learning algorithms continuously analyze energy consumption patterns and identify opportunities for savings. Many organizations are reporting significant reductions in energy costs while simultaneously reducing carbon emissions. This creates both economic and environmental benefits. Predictive maintenance. Traditional building maintenance often relies on fixed schedules or reacting to equipment failures. Digital buildings are changing this approach through predictive maintenance. AI systems continuously monitor. Elevators, air conditioning systems, pumps, electrical systems, fire protection systems, security equipment. Advanced algorithms detect early signs of potential failures before breakdowns occur. Maintenance teams receive alerts and recommendations, allowing them to intervene before costly disruptions happen. This increases reliability, extends equipment life, and reduces maintenance expenses. Intelligent building security systems have become increasingly sophisticated. Modern digital buildings use AI-powered technologies such as facial recognition, video analytics, intelligent surveillance, behavior analysis, automated access control, intrusion detection. AI-assisted software development enables rapid deployment of these advanced security capabilities. Building operators can identify potential threats more quickly and respond more effectively. The result is a safer environment for occupants and visitors. Occupant experience and well-being. The future of buildings is not only about technology but also about people. Digital buildings can enhance occupant well-being by monitoring and optimizing indoor air quality, temperature, humidity, lighting conditions, noise levels, workspace utilization. AI systems can personalize building environments according to user preferences. Imagine entering an office where the lighting, temperature, and workspace settings are automatically adjusted to your individual needs. This level of personalization is becoming increasingly achievable through intelligent software systems. AI-assisted software engineering for building applications. Software engineering itself is undergoing a major transformation. AI tools can now assist developers throughout the entire software lifecycle. Requirements analysis. AI helps identify user needs and system requirements. Software design. AI recommends software architectures and design patterns. Code generation. AI generates code for building applications automatically. Testing and quality assurance. AI performs automated software testing and defect detection. Cybersecurity. AI identifies vulnerabilities and strengthens security protections. Maintenance and upgrades. AI assists with software updates and continuous improvement. These capabilities allow development teams to focus more on innovation and less on repetitive coding tasks. Future opportunities. The future of digital buildings is extraordinarily exciting. Emerging technologies likely to shape the next generation of buildings include AI agents, autonomous building management systems, quantum computing, quantum AI, advanced robotics, smart cities integration, autonomous energy networks, digital construction platforms, human-centered intelligent environments. AI agents may eventually operate entire building systems autonomously, making decisions in real time to optimize performance, safety, sustainability, and occupant satisfaction. Buildings may become active participants within broader smart city ecosystems. Conclusion. We are witnessing one of the most important technological transformations in the history of the built environment. Digital buildings are becoming intelligent, connected, adaptive, and autonomous. AI-assisted programming, coding, and software engineering are accelerating innovation and enabling organizations to develop sophisticated building solutions more rapidly than ever before. The benefits include improved efficiency, lower costs, enhanced sustainability, better occupant experiences, stronger security, and smarter decision-making. For building owners, facility managers, software engineers, architects, construction professionals, students, and technology leaders, understanding these developments is becoming increasingly important. The digital building transformation has already begun, and those who embrace these technologies today will be best positioned to lead the smart buildings and smart cities of tomorrow. Thank you for watching. Please subscribe to our channel for more videos on digital buildings, artificial intelligence, AI agents, quantum technologies, smart cities, digital engineering, and other emerging technologies that are transforming our world. If you enjoyed this discussion, don't forget to subscribe, like, and share. Stay tuned for more insights on AI, quantum computing, and emerging technologies shaping the future of software and humanity.